Well, good day. Here is Discrete Set Theory 2, and the title of our lesson today is about the empty set, and the notation symbols is an element of or is not an element of. So those are going to be the two things that we're talking about in this video, and let's get started with the empty set. First of all, what is the empty set? Well, number one, it is a set of no elements. So it's not, let me tell you what it's not. Number one, it's not zero. Okay? It's not zero. It's a set of no elements, which means it's just a set that has nothing in it. So if we use the roster method to write down the empty set, the way we would do it is we would do it like this. So that is one symbol for the empty set. The other symbol, to distinguish it from zero, because it's not zero, is that we would use a zero with a slash through it. So this is the notation for an empty set. Now, for instance, what we'd like to do is we'd like to talk about which kinds of things are an empty set. Okay? So I would like to say that suppose we have the set of presidents of the U.S. and the set of presidents of South Africa. Alright, the Republic of South Africa. Now, suppose, and let's call the set of U.S. presidents set A and the set of South African presidents set B. And suppose I ask, what is A intersect B? And we're going to talk about intersect a little bit, but what I'm saying is, do they have anything in common? And the answer would be, they don't have anything in common, so that's equal to the empty set. Another way you can think of this in terms of empty set is you can think, what if I had this set of all X such that X is a woman U.S. president. Alright, and that's in set builder notation. Well, that's also equal to the empty set, although I think probably in the next, well, it could be in the next 3 to 10 years, I imagine that we'll probably elect a woman, so that'd be pretty cool. And so these are the kinds of things. You could do it more mathematically. Suppose I have the set of X such that X is less than 2 and X is greater than 3. Is there any number that can be less than 2 and greater than 3 at the same time? Answer is no. So that is the empty set. So a couple of things I want to clear up about the empty set. Sometimes people think that this is the empty set because it's a set that contains 0. But what you have to remember is 0 is actually a number. It's actually a number. And therefore, it's an element, so it exists. So this is actually a set that contains one element. Therefore, it's not the empty set. Okay? So those are kinds of things you have to remember about the empty set, and so you don't get fooled along the way. So the next topic for our lesson is the topic of the symbols is an element of and is not an element of. So what we do is we use these when we're asking if elements are actually the part of a set. So for instance, tell me if this is true or false. What if I say 0 is an element of the empty set? So what do you think? Yes, that is false. Why is it false? Well, because the empty set has no elements, and 0 is actually an element. So this is another way to say what we just said up above, that a set containing 0 is not the empty set, or even a single element 0 is not the empty set. So this would be a false statement, and to make it true, I would have to do that. Okay? So let's do a few examples of is an element of and is not an element of, so that you can see how this works. So suppose I have R. Is that an element of the set containing A, B, C, ellipsis, Z? So what do you think? That's exactly right. That is a true statement. Okay, let's try another one. 7 is not an element of the set of 1, 2, 3, 4. True or false? That's right. That's also true, because 7's not a part of that set. Okay? Make a little more sense? Here's a couple of others you can do. Let's try this one. R is an element of A, B, C, Z. And the answer to that one is false. Notice it didn't have the ellipsis, so it's not the whole alphabet, so it doesn't include R. So that one would be a false statement. And so your job is going to be to really distinguish on this assignment whether sets are the empty set or not, or whether they whether you have things that are elements or are not elements. And so the assignment will concern these problems. They'll be focused approximately on problems 34 to 66, and that's where your assignment will be, and I'll tell you which ones we're doing tomorrow in class when you get to class. One other thing I want to talk about just before you go. Let's mention in your textbook, when you see a bold letter like this, it usually, and this is not a very good example of it, the way we normally write it in mathematics is we do a capital N and then do a double line, and that means it's bold. But in any case, this is called the set of natural numbers. And they're called natural because all societies tend to know what these are. We often call them the counting numbers as well. And the natural numbers in the roster method are the numbers 1, 2, 3, 4, ellipsis. They go on forever. So using some of our element is not an element of, for instance, you could say 5 is an element of the natural numbers. Is that true or false? That, of course, would be true. And you could say 1/2, is that an element of the natural numbers? And in this case, that would be false. All right? And then, of course, if you made them not an element like that, then this one would be false and this one would be true. So you can ask the opposite question. So really pay attention to this symbol as you start to look over these problems, and I'll assign them in class tomorrow. Okay, thanks a lot.